So this is going to be part one of our networking lectures because it's kind of a really complex topic, so it's split into two. But first, we're just going to talk about some logistics and some announcements. The last day to drop is November 20th, and we've been getting a couple questions on Piazza about whether this is to drop without a W, and yes, this is. So as long as you drop before then, you won't get a W on your transcript. And just a reminder again that extensions must be requested at least 24 hours in advance. And please request extensions on Piazza with a private post, because if you email us separately, there's a chance we might not see it, and the best way to get or reach us is through Piazza. And then we're also introducing our HACC Challenge today. And if you weren't familiar, the HACC Challenge is what we call our required final project for this course. And in this challenge, you'll work in teams of 3 to 4 members from at least iOS and backend, and you may potentially have someone from design on your team as well, and you're going to work together to create a fully functional app, and you guys are also going to think of the idea for this app. And then this spans roughly like 3 working weeks, so it'll go over Thanksgiving break, but you'll have like roughly 3 weeks like campus time to work on it, so excluding Thanksgiving break. So a rough timeline kind of doesn't really make sense unless you look at it on a calculator. But the proposal, which is your ideas, will be due November 8th, which is the coming Friday at 11:59 p.m. And then HACC Challenge Kickoff, which is when you'll form teams, is going to be next Monday at 8:30. So that's immediately after this lecture. So if you're in the backend course as well, it's going to take place during the backend course right here. So there's no backend course next week. So this is like mandatory. You have to be there to get a team, and it's a required final project, so make sure you can be there. And then you'll all get a iOS mentor, so someone on the course staff to mentor you throughout the project, and you have to have a midpoint check with your mentor at some point between November 20th and 22nd. And then once you meet with your mentor and go over any final adjustments for your midpoint submission, you'll submit that on November 22nd. And then you'll keep working, so we'll have Thanksgiving break, and then there's a little bit of time before the final submission is going to be due on November 8th at 11:59 p.m., which is a Sunday. And then HACC Challenge Finale. So HACC Challenge has a couple of award categories, and HACC Challenge Finale is where we'll present who won those categories and give out prizes for those awards. And that's December 9th at 7:30 p.m., so that's a Monday at 7:30 p.m. right here, so during this time slot. And then in terms of the requirements for the HACC Challenge for iOS, number 1 is that you must use auto layout. So you can use NS layout constraint, which is what we've been talking about so far, or we're going to introduce something today called SnapKit, which is also another way to do auto layout. You can pick one of the two to do it, but you must use auto layout, so no frame-based code. 2 is you must have at least one UI collection view or UI table view in your app. So the past 2 lectures, you must have at least one of those. The third requirement is that you have to have some form of navigation to navigate between screens. So if you think about the project with the red squares and blue circles, we can navigate to the red square arena, go back, and then navigate to the blue square arena. It doesn't have to be like that back and forth, but you have to have some form of navigation. So in that project, you use a UI navigation controller. There's also something called a UI tab bar controller, which we haven't covered in class, but if you were interested in using it, that's another way you can achieve navigation. And if you think of the Photos app, or I think the Clock app, they have little icons on the bottom that you can tap, and then it'll switch screens, so that's the UI tab bar controller. And the fourth and final requirement is that you have to integrate your app with an API. And the API must provide meaningful value to your app. So for example, if you're doing some sort of music app, Apple Music has an API that you can use to get songs. So this is in contrast to the project where you guys made a playlist. You just hard-coded information into Swift. So instead of doing that, you would communicate with the Apple Music API to get information. But for most of the projects, because you're working with backend course members, you'll integrate an API that they've created for the purpose of your app idea. Does anyone have any questions? Yeah.
So, it's just us who's making the proposal, or you'll have to come to a compromise if you create some backend team with their own ideas.
So everyone has to submit a Google form, which is the proposal submission, and then that's going to be due on a Sunday, so we'll release all the ideas over the weekend so you guys can read through everyone's ideas. And then on Monday at 8:30, so next Monday, is team formation, where you'll get to kind of talk to other people about different ideas that people proposed and form teams that way. So you may not necessarily work on your own idea, but you'd work on someone like else's idea that you were interested in. Does that make sense? Does anyone have other questions about Hack Challenge? Cool. And then we're going to move into review. So reviewing collection views. What is one reason you would use a UI collection view over a UI table view? Yeah.
C.
Yeah. So the answer is C. You can scroll in both directions, so vertically or horizontally, and use a grid layout like the photos or camera roll. If we look at the other answers, A is not right, but B, you can display rows instead of a grid more easily with a collection view. If we think about it, a table will just default to rows, so it's probably easier with a table view. And then D, collection views are easier to set up, is also not necessarily true because of the weird like sizing constraints we have to put, or you can consider them equivalent in like easiness of being set up. All right, and then how do you set the spacing of a collection view? Yeah, so you're right. You can't set the spacing of a collection view just by doing like collection view dot something. You actually need to set the spacing of the layout. So like we did in the last demo, we defined a layout variable that was of type UI collection view flow layout, and then we did layout dot minimum line spacing and minimum inter item spacing. Cool. So moving into the topic for today, which is networking. What this basically means is connecting your app to the internet. Why do we want to do this? If we take this example here, which is just a Facebook feed, how we could think about doing this right now is creating like a post model. Like we've created song models, restaurant models. So if we created a post model with the title, number of likes, number of comments, and then use that as an array to feed into like a table view or a collection view to create this. But there's a couple issues with this. One, it's like static, so it doesn't pull any information like live information. If you wanted to say someone made a post at like 2 a.m., you'd have to go into your code base, create a new post variable, put it in your array, and then like relaunch your app, which is obviously not very feasible or convenient. Secondly, there's an issue of like scalability. So there's tons and tons and tons of posts on Facebook. And if you stored all that information just in your code, like we have been for the past couple apps or projects, that would like blow up the size of your app and be not feasible for like real use. Cool. So how do we actually connect our apps to the internet? We do this by making HTTP requests, and they're basically a form of communication between clients and servers. So in the case of like iOS apps, your app is a client and the server is like somewhere on the internet. That's a little hand wavy, but just think of it that way. So if you look in the graphic, client communicates to the server through the internet, and you guys actually make HTTP requests like every single day. And if you think about like going to google.com, that's making a request. So we're just going to use this tool called Postman. You guys don't really have to worry about this, but it's just demonstrating that like if I go to www.google.com and I'm going to send my request, so I want to communicate with like Google server, I get back this response from Google, and we can see that this response has like HTML format, so this is probably like the HTML layout of Google today. We can kind of tell, oh, today's like Google logo is for someone's 140th birthday. But yeah, if you notice here, there's like this get, and this is like the type of request. So right now we're trying to get information from Google's website. And if we open this, we see that there's actually tons of types of HTTP requests you can make. But for the purpose of this course, we're only going to talk about 3. So not Xcode. So yeah. The 3 that we're going to focus on is a GET request, which is the one I just demonstrated, a POST request, and a DELETE request. And like I showed in Postman, there's a lot more that you could possibly do. So a GET request is used to retrieve or get data from the server. A post request is used to send data or like post data to your server in order to create or update some model. So if we think about the Facebook post example, our model is our Facebook post, and if I wanted to create a new post, I'd send a new like post object, or if I wanted to update a post, I could just send over the new information that I wanted to update for a certain post, like increase the number of comments. And then the third type is a delete request, which is what we use to tell the server to delete some model. So say I made a really, really embarrassing post on Facebook 4 years ago and people are finding it and I want to delete it. I could just send a delete request to like my database to tell database to get rid of that post. Does anyone have any questions about HTTP requests? Cool. So we're also going to talk about JSON, which is JavaScript Object Notation, which is kind of like a format that data can be like represented in. You can think of them as being very, very similar to dictionaries because they have key-value pairs. And the keys are always strings, but the values can be like almost anything you want it to be. So like strings, objects, numbers, booleans, arrays of any of those types, or just null are options for your values. So in this example here, we have a very simple JSON. So the keys here are name, number, and instructors. And we can see that they all have different types for their values. So name has values of type string, number has a value of type integer, and instructors has a value of type array of strings. Yeah. Does anyone have any questions about JSON or not quite understand how this is formatted? Cool. So why do we actually care about JSON? Why did I just talk about that? That's because servers often send data back to us in JSON format. So in the example with Google, they actually sent back HTML, but for most cases, or for like the APIs that you'll be using for your Hack Challenge projects, most of the time it's sent back in a JSON format. So we call the data that we get back the response from the server. The response will be in JSON format, so we need to understand how JSON is formed so we can parse it correctly and decode the information from the response. And then one way that we can like integrate networking is by using external libraries. So external libraries allow you to like reuse or use code that other people have written to like save time. So oftentimes I'm sure you've been like doing something, whether it be in like iOS or like some other sort of programming class, and you're trying to accomplish something that is very, very commonly done. There's probably someone out there who has developed that literal same piece of code as you, and like you're just writing it again. So external libraries are like code that people have put in some sort of library manager that allow you to kind of like download it and use it so that you don't have to like rewrite that code all over again. And basically this is just a huge time saver for us. And then the way that we use libraries in Swift is using Cocoapods. So Cocoapods is an external dependency or external library manager for Swift and Objective-C. And there's tons and tons of libraries put on Cocoapods that people use like all over the world. And it just provides us with an easy way to manage, download, and use third-party libraries. And if you've coded in Python or Node before, this is very similar to pip or npm in both of those languages. Does anyone have any questions about like what external libraries are or how Cocoapods like helps us use them? Cool. So if we look at the apps on AppDev, so these are just two, we actually use tons of pods in our app. So looking at the right, we have Ithaca Transit, and we actually use a Google Maps library that basically just allows us to put like the Google map into our app. And then Eatery on the left actually needs a video to demonstrate. But yeah, so if we look at Eatery here, when we tap on it, it has this nice animation where the like picture grows up to fill the top half of the screen. The way that is implemented, we didn't actually write. There's something called the Hero Animation Library, which is a Cocoapod that we were using for the animation that we just showed you. Cool. And then how to use Cocoapods. So there was a post on Piazza earlier today with instructions on how to install Cocoapod that you guys should have followed. Does everyone who like wants to follow along with the demo today, have they downloaded Cocoapods? Cool. So if you haven't, that is the command that you would run in your terminal to first install Cocoapods, which is the first step to being able to use it. And then the concept of like using a Cocopod is that you need a pod file that specifies all of the like external libraries, or Cocoapods, we refer to them as pods. It specifies all the pods that you want to use in your project. So what we'll do is we do pod init, which will create like a blank pod file for us, and then we type inside our pod file to specify. So we're actually going to start the demo by creating the pod file. So if you guys open a terminal window, let's make this font a lot bigger. Can everyone see that? Cool. So first we're just going to go into Finder and find where you put your project. So go inside the folder. I don't know how to make this bigger, but go inside the folder with your like Xcode proj file in it. So here, go inside the folder that has your Xcode proj file in it. And then if you just drag this folder, and you can drag it into your terminal by like dragging it over it. Wow. Or not. Mine is open over here, so we're just going to drag it here. But drag it into your terminal and just drop it, and then press enter. This will navigate to where that folder is. So right now we can say we're inside this. So if you do ls, it'll list all of the projects that are in there. Oh, I did this wrong. I dragged the wrong thing. Let's go back to desktop. Okay. Just drag the whole like outer folder to your terminal. Yeah, so you want to be in L6 starter and not like your actual Xcode proj. And then just press enter and you'll be inside the folder that has the project. And if you do ls, which just lists all the files in the folder you currently are in, we see we have the Xcode proj. So make sure you can see that. And then what we want to do to like initialize our pod file is pod init. Okay. And then if you do ls after that, you'll see that it created this thing called pod file. Cool. Did everyone get like a pod file to pop up? Cool. And then if we just do open pod file, this will open your file in like, I think this is just text edit. And then you should just have like, this is like a very blank pod file that basically just has the boilerplate code and doesn't actually have any pods that it wants to install specified. And the way that we can add a pod, we use the keyword pod and then a single quote and then the name of the library you want to install. So for the demo, we're going to use AlamoFire, and we're also going to use SnapKit later, but not today. So we're just going to do pod SnapKit. Cool. Did everyone get the pod file with the pods in it? Cool. So just save that. And then if you, does everyone have it? Okay. And then if you go back to your terminal, do pod install. Wow, I cannot read that. You'll see that it installed AlamoFire and installed SnapKit, and then you can ignore the rest. Did everyone get this? Does anyone have any errors?
Mine's mad about, I didn't capitalize the Snapchat.
Yeah. You just have to make sure you spell like the pod name correctly. Yeah. Cool. Yeah. Yeah. Cool. Everyone good? Cool. So going back into the slides for a sec. We just went over this, but like this is an example pod file from Polo, which is one of AppDev's apps. So you can see we have AlamoFire and SnapKit as well as a couple other pods that we're using in Polo. So we just ran pod install, which installed the libraries into our L6 starter project. And then what this does, if you check your Finder now, you'll see that you have something called l6starter.xc workspace now, instead of just, or you're still going to have XC project, but now you have XC workspace as well. And then this is the file that you want to open in Xcode now and work in. So you don't want to work in your XC project file anymore, because if you want to use the libraries, you have to be in the XC workspace file. Cool. So this is the demo that we're going to do today. So this demo is kind of split between this lecture and next week's lecture. And today we're just going to learn how to grab this JSON, which is hosted on the internet. So this is going to act as our API. We're going to take that and then try to get the response in Xcode. Cool. Open. Yeah, so when you're opening your project now, make sure you're opening the XC workspace. Oh, that's not it.
There's some slides on SnapKit before this.
They go after.
Oh, afterwards.
Yeah.
Okay.
Okay guys, so if you take a look at the starter code, you'll notice that we have a navigation controller, and inside that we have a view controller, and that's right here. And on the slides you saw this sort of list of courses, and that was going to be a table view. But we're not actually going to show the UI right now, we're just going to show you how to actually fetch and make a network request in iOS. So yeah, we have a table view here, and we have some constraints for it, and then we have this function called getCourses. So here's where we're actually going to make a request to a URL and fetch some data. So if you notice, we have this model called course. So it has name, code, instructor, this property called enrolled, and we also have this file called network manager. This is something a little bit new. So we have this URL here, and it's just a string. And if we actually go look that up, where is it? You got it. So if we look this up, we get this JSON object. So we have this data key value pair that has this sort of list of classes. So each class has the same exact structure, and if you notice, it's the same exact structure as our course model. So what we want to do is actually fetch this data and parse it inside our app. So let's go ahead and do that. Cool. Okay, so first things first, we're going to create a class called a network manager. But this will be a different class than what we normally do, because normally we have an initializer with some parameters, but we're not going to do that this time. We're not going to actually create an instance of our network manager. We're just going to put all of our network requests inside this class. So the way we can actually do that is by defining a function, a static function called getCourses. And what we mean by static is that we don't actually have to create an instance of network manager to call this function. So if I go to view controller and I call this function here, it's not going to yell at me. And that's because I don't have to do this right here. I don't have to create an instance of this class. I can if I want to, but I don't have to. So the reason why we do that is because, in a big app like Facebook, like Yana talked about, you have all sorts of network requests going on. So we want to put all of those requests inside a very handy class like Network Manager. So what we're going to do is actually try to get that data that we showed you. So once you actually run pod install, that will install AlamoFire in your app. So up here, we're going to actually import it. Or is it not? No such module. Yeah, sometimes it's a little bit delayed. If I try running the app, it'll probably stop yelling at me. Okay, yeah, it's good. It might yell at you at first, but don't worry about that. So we're going to use AlamoFire. And this library actually has a lot of provided functions that you can use to make network requests. So the first function we're going to actually look at is request. And it takes in a URL, a method, and then a bunch of different arguments that we're not going to talk about yet. But right now, we actually have a URL, and it's a string, so we can pass that in here. And like Yana was saying, we're just going to do a GET request this time. So this is actually an enum, and you see we have a bunch of different types. We have GET, PUT, POST, a lot of common types of requests. But in this case, we're just going to do GET. And you guys can delete these arguments here. They're not going to matter for now. Okay. So now, this is kind of boilerplate code for AlamoFire, but we have to call this .validate to actually validate the request. And then we have to call response. We actually want to get our response. We want to run a function once we get a response from our request. But if you notice, back here, this is a JSON object. So there are different types of requests or responses that you can get using AlamoFire. And notice if you see in the autocomplete, there's response data, response string, but we want to focus on response JSON because we have a JSON object. So if I do that and I tap enter, you're going to see a different type of argument here. This completion handler is actually a function type. So that's saying, okay, once I actually get a response from the internet, I want to execute this piece of code. So if you tap enter one more time, we're going to get our response. And if I type this in, it's of type data response and any. So this is actually a built-in type from AlamoFire. So you don't have to worry about that too much, but it looks a little bit something like this. I'll write this to make this a little bit easier. So I'm calling it example data response because I can't actually duplicate the exact name. So it's going to look like this. So we're going to have an enum, and it's either case success or case failure. So if it's success, you get this data back. If it's failure, you get some sort of error. So this is a different type of enum than what you guys... Yeah, you have a question?
Yeah, wait. Can you explain the response in response part again?
Oh, yeah. So response in, this is something called a closure. We'll talk more about this in the coming weeks, but this is pretty much a function that will get executed once you get a response from the internet.
Yeah, and like response is the name of so response JSON returns a data object, and response is what we're using to refer to that data object. So that's our parameter name. So we can inside after in, the part after in is the function that will be called once it comes back because it takes some time to get the response back, and then we can refer to that using just that parameter name that we gave it.
Exactly. So our response will look very similar to this data type. So this is a new kind of enum. So if you create different cases for enums, you can actually wrap different arguments inside them. And that's what I did here with data and then error. So response looks very much like this. So what we can do on enums, as you know, is we can switch on their value. So we're going to do response.result. It's going to be case success. And this is kind of like unwrapping. We're just going to grab the value from the enum here. And this is going to give us a data object. That's going to be our JSON. So let's just print that out once we get it. Or, for whatever reason, it will fail. And we don't know why, but it'll give us an error telling us why. And we can print that out as well. Okay. So, does anyone need more time to type this out? Okay.
Does this make sense to everyone?
Why is that use like less than or greater than tags?
Oh, yeah. So that is a generic type. So we actually don't know what our data type will be. Next week, we'll talk about how we need to decode the type. But for now, we can just assume it's some generic type T, which is just any type. Yeah. Yeah.
Basically, why response to that result, the type is we can switch using our custom type.
Oh, so the type that I have up here actually isn't related to this. It's just I did that to show that it's the pretty much the same exact structure. So this is just a complete custom type. We're not using that at all, but the response.result type looks exactly like this right here. Yeah. Does that make sense? Cool. Anyone need more time, or are we good? Cool. Okay, so if we go back to view controller, we call this now, and this function doesn't return anything. But let's run the simulator to actually see what happens. Okay. So we actually don't care about the simulator anymore. We're going to care about what gets printed out in the console. So if you notice, this function getCourses gets called in viewDidLoad. And now if I look at my console, we see the exact same object that we saw in our browser. So we made a request, we got some data, and we printed it out.
Did everyone get this if they're following along?
Okay. Okay, so later we'll actually talk about how to decode this data. Because now you notice we have this array of classes, and they all have the same type, which is our course model here. And there's actually really neat and quick ways of decoding large amounts of data into our custom types that we built here. But we'll talk about that next week. But first, I want to show you guys what Yana was talking about, and she'll talk more about it, which is SnapKit. So we installed SnapKit, and in our view controller, let's actually import that at the very top. And when we set up our constraints, sometimes it's pretty annoying because NS layout constraint, it's kind of annoying to type out all of those constraints. It feels pretty redundant. And there's actually a much cleaner way of doing this, which is using SnapKit. So once we actually import SnapKit, every single UI view has this new property called SNP, or Snap, you can call it. And this is actually something that allows us to create constraints. And like we were talking about earlier, this is a closure. In these curly braces, we have this constraint maker that we're calling make, and it can do different things. So it can take the width constraint, and it can give it a value, and we can say equal to superview. And let's say we want to do chains. So up here we set the top anchor, leading anchor, trailing anchor, and bottom anchor just equal to the view's top, leading, trailing, and bottom. But we can actually do that here in a much cleaner way. So we can do make.width, .height, .leading, and .trailing equal to superview. So instead of those, it reduces the number of lines of code pretty much. But because we're pretty much constraining this table view to the edges of our screen, there's something even cleaner than this, which is make.edges equal to superview. So SnapKit is very powerful, and if you do that, you don't have to worry about this annoying property, this really long one here. You can just delete this. You don't have to actually do anything with this anymore. And notice how this is so much cleaner, and it just looks so much better, and it'll be a lot more helpful down the line.
Yeah, so just to kind of recap, SnapKit, It is a Cocopod, so we put it inside our pod file. When we ran pod install, it got put inside our XC workspace so that we could use it. It's just a better way to auto layout, so if you guys want to use SnapKit, you guys can use it for your final projects, but you don't have to if you don't want to. You can still use NS layout constraints. But basically, I mean, on AppDev, we use SnapKit, and it means you don't have to set translates auto resizing mask to constraints or into constraints to false. And like Matthew demonstrated, the syntax is like much more readable, and you can make it a lot cleaner than if you were using ns layout constraint.activate. And yeah, just put it inside your pod file, run pod install, and you'll be able to use it. And then just kind of to like compare and contrast, the top is using ns layout constraints. The bottom is just using SnapKit. You can see these will literally achieve the same exact thing. So for like NS layout constraint, first we had to set this property to be false, and then we have to do this whole like array, so you can't forget your commas, kind of annoying. And then you have to like myView.leadingAnchor.constraint, and then you have to access like your views, leading anchor, and all of that. Whereas in SnapKit on the bottom, we can just do dot equal to superview, and we don't have to do like equal to superview dot leading anchor. And then there's just the offset padding. Offset padding that you can attach onto the end of basically any make dot something to just add padding in between your constraints. And then just on the last two lines, we did make dot top equal to superview and make dot bottom equal to superview. You could condense those and chain them just to be make dot top dot bottom equal to superview, which is also another thing that's really nice about SnapKit because there's no way to do that with NS layout constraint. Does anyone have any questions about SnapKit? Yeah.
How do you set like specific offset, like left or right constants?
Like
That's just
padding is just like a variable name. Yeah. So you're gonna put an email. Yeah.
How would you set it to, like, if you wanted to set the top one to the bottom of like a different element, like how would you do that?
So you can actually just access dot leading of any other view. So like before we would do like, say I had another view called view2 and I did myView.leadingAnchor.constraint equal to view2.trailingAnchor. You can just access, for SnapKit, you just do equal to view2.trailing. Cool. And then some action items. The hack challenge proposal, so your idea submissions will be due on Friday. So this is not Sunday like our assignments are normally due, so keep that in mind. So they're Friday at 11:59 p.m. and then you'll be able to kind of like read through them over the weekend so that when you get to team formation or hack challenge kickoff on Monday, you can kind of gauge everyone's interest and form teams. And then we have an extra credit assignment, so there's no like formal project for this week. We have an extra credit playground assignment. So playground, like similar to project 1 where you just worked in a playground and didn't create like an app on the simulator. And it's going to be on closures. So we kind of touched on closures a little bit with the like response in and make in for SnapKit. So if you want to get a little bit more familiar with what those are or how they work, this playground has really detailed explanations or comments about how they work. And if you choose to do it, that'll be due November 10th at 11:59 p.m. Cool. Does anyone have any questions? Cool, that's all.